So we need to prove the following. So let us begin. So we'll start our problem from the left hand side. So here we have sine of 3a multiplied to sine cubed a added to cosine of 3a times cosine cubed a. So what we'll do, we'll use a formula here. If we expand sine of angle 3a, so that gives us 3 times sine of angle a minus 4 times sine cubed a. Now if we isolate sine cubed a, so sine cubed a will then become equals to 3 over 4 sine a minus 1 over 4 times sine 3a. So what we'll do, we'll replace this value of sine cube a with this particular value. So let's do that. We get sine 3a multiplied to 3 over 4 times sine of angle a minus 1 over 4 times sine of angle 3a added to cosine of 3a. Now what we'll do, we'll use another formula, which is the expansion of cosine of 3a. So cosine of 3a is given by 4 times cosine cubed a minus 3 times cosine of angle a. So if we isolate cosine cube a from here, so cosine cube a will become equals to 3 over 4 cosine of angle a plus 1 over 4 cosine of angle 3a. So we will replace this cosine cube a with 3 over 4 times cosine of angle a added to 1 over 4 times cosine of angle 3a. Okay, so now let's distribute. So we have 3 over 4 times sine of angle 3a times sine of angle a minus 1 over 4 times sine squared 3a added to 3 over 4 times cosine of angle 3a times cosine of angle a added to 1 over 4 times cosine squared 3a. Now what we'll do, we'll take 1 over 4 as the common factor and combine the second and the fourth term. So we have 1 over 4 multiplied to cosine squared 3a minus sine squared 3a. And then we're going to combine the first and the third term by taking 3 over 4 as the common factor. So that gets multiplied to cosine of 3a times cosine of angle a plus sine of angle 3a times sine of angle a. Fine. Now cosine squared 3a minus sine squared 3a, that's a standard formula. We know that cosine squared theta minus sine squared theta. So that's given by cosine of 2 theta, which means that we will get 1 over 4 times cosine of 2 theta, but theta here is 3a. So we have 2 times 3a plus 3 over 4. Now here we have another formula. So here we have the form cosine of theta times cosine of phi added to sine of theta times sine of angle phi. So this is given by cosine of the angle theta minus phi. In our case, we have theta representing 3a and phi representing a. So this will be simply equals to cosine of the angle 3a minus a. Okay, so let's further simplify. Now what we'll do, now we'll take 1 over 4. Now instead of writing it as cosine of 2 times the angle 3a, we're going to rewrite it as 3 times the angle 2a plus we have 3 over 4 times cosine of angle 2a. Now what we can do, we can use the formula for cosine of angle 3a. So here a was actually 2a. So wherever we see a, we're going to replace it with 2a. So that means we're going to get 1 over 4 times, this will be multiplied to 4 times cosine cubed. We need cosine cube a, but we're going to replace a with 2a minus 3 times cosine of angle a. Cosine of angle a will be replaced with 2a added to 3 over 4 times cosine of angle 2a. Fine. So now we have cosine cubed 2a minus 3 over 4 times cosine of angle 2a added to 3 over 4 times cosine of 2a. Now we can cancel out the second and the third term, and that leaves us with cosine cubed 2a, which is the expression on the right hand side. So therefore, we have successfully showed that the left hand side equals the right hand side, hence proved.